Hello everyone, it's Mr. 13 Things again, coming back to you in the second part of what you really learn to do when you're learning to run your calculator. I'm going to come back and kind of go back to one thing here, and that was in the first one. You ask it a question. The first thing you do is, besides turning it on and check the batteries, is ask it a question. Ask it a question of which you are sure. And for us, that becomes, I think, the tangent of 45 degrees. And you'll start to realize why, as you get into more mature systems, you're going to need to put units, and degrees is a unit. So if you ask it the tangent of 45 degrees, you'll get one of two answers. So what's the answer you should know? Well, if something has a length of 1 here and a length of 1 there, that's 45 degrees. Opposite over adjacent is 1. So the tangent of 45 degrees equals 1. That's how you can actually approach that very quickly, very early with kids, especially if you go out on the right time of year and look at the sun. But as you progress up, and hopefully kids will have learned a lot more than that. They would have learned the tangent of 45 and the tangent of 30 and the tangent of 60 being a pattern. 1 over the square root of 3. And that's how you start to kind of play around and build on some basic information on a calculator. So you ask it a question in which you are sure is the first thing you do. Let's see if I can do an edit cut here. I can do that. No, it did not like that. Oh, it kept working though. Alright, so the next thing you can do, as we mentioned before, is you can learn where everything can be gotten. So we're going to turn on the calculator, and remembering that you can go alphabetically to anything right there, and you have to actually learn the idiosyncrasies. So as you go up and down, you can go to the bottom of a list by going up. And you can then also just use an alpha B and it will jump clear. I missed that there. Once again, you're going to go second catalog, clear. All right, I can go down here, and now if I do alpha G, it should jump down within my alphabetized list. However, menus, and kids are used to using menus in something called drop downs or a cascading list. So there is a functionality and a thought process that goes into knowing where things are at. So for instance, second quit, learning the difference between a test condition, right, or a regular old equals, right, is going to be one thing that becomes important as you start looking at logic being all put in to one spot here, where in computer language usually the test condition is going to be double equals. So this is not such a great example of that. But knowing that things are put into places, the most important places I will tell you besides that are grouped are the lists and the matrices. So learning that you, at least on this calculator, when you're doing matrix math, you have to go to the math portion that's under the matrix, or the editing under the matrix. And if you are doing list math, kind of odd, you have to do to the calculation when you're dealing with lists. So you're going to see later there's a great relationship between lists and matrices. Many ways it could be considered to be the same. The first thing you do is ask it a question of which you are sure. The next thing is to draw a line. If you remember, in this graph, y equals x. And once again, window, how things get screwed around, we can go to zoom square. If I go down here. Now it's back to that 45 degree, though everything is off-centered. Now, the next thing you can do is learn how to change some of your, there it is, we really want that to be radians perhaps, and we might want that now to be parametric for this reason alone. Now if we go to y equals x equals cosine of t, and y equals sine of t. I don't like the capital T, but it'll have to do. And we graph it. Once again, we show it a circle that something we know the answer to, and we can once again zoom in. I think it does something like this. And window, zoom out. And all you're doing when you're zooming out here is you are changing the values in the window. So you're learning to go and realize that these windows change. So this is going from 0 to 2 pi with a time step. X minimum will go with minus 1.6 if you remember. Minus 1.6. Doesn't like that. I'm just going to key it down here. Remember, there is a minus there. It's very different than the subtract sign. Minus 1.6 to 1.6. And the y minimum is minus 1 to 1. And when you graph it, you get a circle. Remember how that function should look like a circle, and now you're realizing you can't necessarily mix and match, but in this case you can go down and do your section function where x is t and y is t, and you get back to that graph of, because t went from 0 up, you have the 45-degree line there, and you can start very quickly realizing that the only way to deal with the world is not by looking at it in one mode. In other words, by looking at it in a parametric mode or a function mode, standard math, or a polar mode, or sequences, when you get to Taylor series, you'll learn from your calculator that the way to solve problems is to look at them through different lenses and with different filters. So, what are you learning when you learn to run a calculator at a deeper level than just answering math questions? One, you learn that you can trust machines, but only when you truth them on a regular basis, asking them a question of which you know you are sure. Two, you learn that you do not want to untrain everything you've learned since you were an infant. So you would like to keep the visual field or the scales to something that you can comprehend until you can deal with it otherwise. Three, you learn that you solve problems by looking at the same problem through different lenses, different disciplines, if you would, or different ways of applying mathematics to them. All that is what comes to you when you look at setting the mode. It is not just about solving a particular problem. I think I'll end it there. Thanks for listening.